So welcome to the ioGAS 8.3 webinar. So 8.3 is in this feature, we focus on improving a lot of the things that we've added in the previous version, which is ioGAS version 8.2. And the biggest thing that we've added in here is the ability to improve the way that we interact with the drill hole module. So we've added the color strip block, which is like the same thing that we had before 8.3 or before the drill hole module was added in 8.2. So when you change things in the attribute manager in a color tab, you'll see that being reflected in a drill hole module as well. So that's one of the biggest things we've added. And alongside a couple of new visualization, if you're bringing in structural data into ioGAS. So now we have tadpole and scat plot as a new way of looking at structural data in ioGAS. And aside from that, in the last release, we've added the ability to merge data from different interval tables together. So merging, say, your assay table with your lithology interval table together. So you could do that in 8.2 quite easily. But in 8.3 now you're able to merge point to intervals data. So say, for example, if you have some XRF data, XRF reading, which is usually, when you're taking your XRF gun on a core, you measure the depth of that measurement, and you want to merge it with some log geology. So previously you couldn't do that in GAS, but now you're able to. And another application is in merging things like downhole structural readings. So your dip and dip direction of your veins, for example. So those are depths in space, and then you can now merge it with assay tables or interval tables, which is what I'm going to be talking about in my demo later on. So another big thing that we've added in this release is the Python script launcher. So this allows you to run Python scripts from within ioGAS. So if you already have a workspace in ioGAS, and if you want to run things in Python, you can do it from within ioGAS. And this will be sort of a big part of the later part of my demo later today. And another big thing that we've added is the fact that we only now have one installation launcher for ioGAS. So whereas before, if you're trying to bring in a large data set into ioGAS, you're sort of limited to the default executable file only supports 6 GB. That's the default. But the new installation basically allows you to utilize as much RAM as your computer has. So effectively, you don't need to select from the other executable file in order to bring in a larger file into ioGAS. And we've also made some improvements to the way that you can export plots out of ioGAS, so you can standardize the size of the plots and things like that, and sort of automate sort of that process. And I'll run through that in a minute. And another thing that we've added is, or change, is the way that we can now auto attribute polygon individually in a classification diagram. So whereas before, if you want to auto attribute a classification diagram, you have to do it as a whole. But now you can do it for each individual polygon on its own. So there's a workflow there that I want to show you in the demo later on. And then there's also different ways now that we can use the attribute manager. And I call that rapid data attribution. So when you create a color group to attribute your cluster of data points, the attribute manager now actually creates those groups automatically for you as you start attributing them. So this is one of those things that makes more sense when I start running through it in my demo. So I'm going to go through a few slides just to show you some pictures of what the things that we have in 8.3, and then I'll jump straight to the demo. All right, so we have tadpole and scat plot in ioGAS now. So this is a way for you to visualize your structural data. So if you have your dip and dip direction of your structural readings, before this version, you can display them as numeric data down the hole, but these plot types are pretty specific to displaying this type of data down the hole. So the tadpole plot displays the orientation of your structural reading. So that's the direction of the arrow where it's heading in the plot, and then the distance along the x-axis, that's the angle of your the dip angle of your structural features. Your scat plot disaggregates between your dip direction and dip data, so displays them into two plots, and so you can display this information in quite a sort of an intuitive manner. So I'll run you through this in the demo in a bit. The color attribute strip log makes a return in 8.3. So this was something that that people use quite a fair bit in the old version of the drill hole module, and we've now sort of we've made it better, right? So it looks exactly like a text strip log, which is what we introduced in the last release. But the difference is it updates automatically based on the state of your attribute manager. So whenever you create a new color group, it gets reflected in real time in this color attribute strip log. And another big thing we've added is the multi-trace stack strip log. So we've always had this. We had this in 8.2, but what's different in this version is that if you're bringing in data from different units, so if your assay data has a mixed unit of percent and ppm, essentially what it does is it will detect if you are bringing in a mixed unit set of columns, and it converts everything into the same unit prior to displaying them in the multi-trace stack strip log. And if you have point data, so this is what I was talking about earlier. So if you're starting off with a point data set, and if you want to merge in some intervals table, you can now do it easily from within ioGAS. So the existing interval join tool, which we had before for merging two interval tables together, is now adapted to be used for merging an intervals table to a points table. So an application would be if you start off with some structural readings, which is usually in a points sort of table, you can merge that with the assay interval tables and things like that. So that's the example that I'm going to show you after this. So yeah, and the Python script runner or the Python script launcher is obviously another big thing that we've added here in 8.3. So the ideal use case for this will be if you're already using Python in sort of your day-to-day workflow, you will have access to your Python script from within ioGAS. So if you already have Python enabled in your environment, you don't have to go outside of ioGAS to run those scripts onto your ioGAS workspace. So the workflow will be if you already have some interpretation done in ioGAS, you already process your rows, you plot them up, and you create some geochemical classification diagrams. And then if you want to run some clustering algorithm, for example, that you don't have in ioGAS, but you have a Python script for it, you can do that in Python and then push the result back into ioGAS as a new column. So that's one example of how you can use this. And you can also use the Python script launcher to actually bring in data from outside of ioGAS into the program. So an example of this would be if you have a Python script that, for example, reads a LAS file, so a typical LAS file that doesn't have sort of the headers that ioGAS need. So it sort of strips the headers and put it into the right format to bring into ioGAS. So that's just one example, but another example would be if you want to, if you have a Python script that say combines several different tables together and then bring them into ioGAS, that's one way that you can utilize this tool. So this is when you start from not having any file open in ioGAS, and then you engage a Python script to actually process some data to bring it into ioGAS. And this single installation launcher thing is what I talked about earlier. So if you have an ioGAS, or if you have a workspace that consists of a large number of rows, in previous version of ioGAS, you have to open a larger executable file. So you have to open, the ioGAS 24 gigabyte XE, which is suited to, because it uses more RAM in your computer, so it utilizes more memory. But in this instance, the new executable file is designed to automatically compute the performance limits of ioGAS based on the RAM that you have in your computer. And if you're talking about, if you use ioGAS to export plots out of the program, we have improved the way that we have export or can export plots out of ioGAS. So you can set the size and the scaling of your plots and standardize it in such a way that you can export your plots the same way every time. So this is not a thing that if you're in academia or if you're doing company reports and you have to export your plots in a certain way, having this standardization option will benefit you from not having to set it up every time you export a plot as sort of ioGAS. I'm going to run you through this in a minute, but basically now, if you right-click on a classification region of a diagram, you can attribute the color based on each polygon instead of every polygon at the same time. So that's quite useful. And this is not a thing that I was talking about, and it's I call this rapid attributing of data points, and it's basically if you're familiar with that type of Scott Haley type workflow where you create a new color group and then you assign a cluster to a color group in a scatter plot, for example. You don't have to create a new color group and then do the attribution sort of every time. So it sort of does that automatically now. So whenever you use the attribute polygon, it will automatically create a new color group and select it for you, and then you just get on your way to start attributing your data points. All right, so I'm going to go through the live demo now, and please feel free to utilize the live chat function if you have any questions at all, or if there's anything that you want the GAS team to clarify. But let's get started. Okay, so I got ioGAS 8.3 open here, and then I'm going to start with opening some structural data. So this file has a stereo net that I can show you. So it has some structural features in here. So if you look in the data column, you have your dip and dip direction. So I can display that either as a stereo net. So I'm just kind of displaying the poles to the planes, or I can display it as a rows plot. And I can change the color of this to my type of structural features. So the thing about the stereo net is that it doesn't have that spatial context. So it doesn't have a context of where they are on the drill hole. So if you go to the drill hole ribbon now, there's a new plot type here called scat plot and tadpole plot. So scat stands for statistical curvature analysis technique plot. And this is grayed out because I don't have any holes selected. So I'm just going to select a few holes in here. So you got to select your holes first, and then it's no longer grayed out. And then just click on the first one. So that's the scat plot. So you display your dip and dip direction in here. So over on the left, that's your dip direction. And it's quite a unique plot, right? So you actually have your 0 in the middle, and then you follow that with the 90 degrees, 180, and 270 degrees over there on the left. And then on the right side, you have your dip angle from 0 on the left to 90 degrees. So the scat plot itself operates on the same basis as every plot in GAS. So you can enable point attributing, which means that you can change the size and the symbology to whatever you set up in the attribute manager. Okay, so that's a scat plot. And then you also have the tadpole plot, which works on the same basis. So the default display is that it doesn't use the colors or attributes from the attribute manager. But the direction of the tail or the arrow in here, it basically signifies the direction of the structural feature. And I can turn on the point attributing color, shape, and size in here, which allows me to kind of see what's what, sort of in a scat and tadpole plot. So let's bring up the legend. I'm going to show you another thing. So this is a new thing that we've added in this release. So if you right click on the legend, you can click on show row counts, and it actually shows you the number of things within each group. So it's like the same thing as you're looking at the attribute manager, right? So you can see the number of rows that corresponds to each group, but the difference is you don't have to open up the attribute manager to get the information. So it's just that number inside the bracket in there. And now we're going to kind of show you sort of how this workflow works, right? So if you open up a stereo net in here, and it functions the same as with any other plot in aiGAS. So you can create a new color group. I'm going to change the size of this a bit. And then I'm going to attribute this cluster. And you can see that being reflected in the tadpole plot, but also in the scat plot. So it's kind of like that attribution of patterns that you see in your stereo net, and see that being reflected in your drill hole space. And you can kind of do the same thing. If I create a new color group in here, and then I can assign, I can do the same thing to the tadpole plot as well. And you see that being reflected in every other open plot in aiGAS. And that includes the stereo net as well. So I don't know if you've noticed, but the list of open windows in here, that has changed a bit. So we now, by default, we sort the plot types we group them by plot type by default when you're displaying your list of open windows in here. So whereas before this was what it used to look like, so we did just display the list of open plot windows, from the order that you display it. But now you can sort it by alphabetical order, and then you can also sort it by plot type. So there will come an example later on where we'll have a bunch of different plots, and that will become really handy. And if you're starting to use 8.3, you might have noticed this. But it's really handy, especially if you have a workspace that has 50 plots and that sort of thing. Okay, so that's a structural sort of module that we have. And as I was showing you before, with this file, the only thing that we have in here is structural readings. So we only have like 12 columns in this file. So it's only structural readings along with some information about what structural features it is. So it's essentially a point. It's a point table, right? So it's a structural reading at a certain depth. But what I want to do now is I actually want to bring in a new table into this workspace. So I actually have a different assay table that I want to merge into this file. So in the classical example, if you want to merge two different tables with different columns into the same workspace in aiGAS, you would use either a join file function, or you can use a reload function. But the thing about the join file function is that it works if you have the same sample ID for the incoming table. But if you don't, in this case, when you're bringing in an assay table to an existing structural table like this, a table that consists of structural readings, you would probably not have the same sample ID. So I'm going to be bringing another table that consists of XRF data, and the XRF data is actually taken from an interval. Okay, so it's an interval-based XRF table. So there's an option in here under drill hole compositing. So it's essentially a drill hole merge tool. So you can join incoming interval to an existing point data, or vice versa, right? So you can join incoming point data to existing interval data. And in this instance, I'm joining incoming interval data to existing point data. So click on that option, and it'll take me to the join file sort of dialog. And I'm going to select the file that I want to bring in. It's going to select that. It's going to take me to the column properties dialog next. Taking a while. But before we do that, we want to actually set the columns that we want to use to join. So remember that we're starting off as a points table, and we want to merge in an intervals table. So you want to configure the columns that you use for depth from and depth to. If you're bringing in if you're starting off with an intervals table, and if you want to bring in a points table, you want to set the same column to be used for your depth from and depth to in here. But now we're bringing in an intervals table, so we just set it to from and to in here. All right, so column properties dialog. So we're bringing in an XRF table, so you got your assay column, and then followed by your error, and then your corrected values, and so on. All right, so we're bringing that into into ioGAS, and the next message that appears is going to ask you want to merge incoming intervals to existing point data, and the answer is yes. So the only other thing that I want to mention is that this tool is only enabled if you have already set your drill holes using the select drill holes dialog. Okay, so the compositing or the joining added this many columns, it merged this many rows, and it tells you the holes that you don't merge because you don't have them in this file. So yeah, so if you look in the data view now, if you go all the way to the right, you see that the XRF data has already been added to the data view. Okay, so that's what the drill hole compositing kind of does. And while we're talking about just bringing in assay data into ioGAS, I'm going to show you a couple of provided resources that we've added in this release. So in the exploration ribbon, if you go to the porphyry copper exploration menu, there's a new diagram in here called the PCD alteration diagram. So it's a diagram that Ross Large has made. It's available now in a paper that he's published this year. So it's an alteration classification diagram for porphyry copper deposit. And the new thing that we've added in ioGAS is the ability to right-click on any diagram polygon, and you can auto-attribute based on each polygon on its own, like this. So instead of clicking on this button on the right-hand side toolbar, which attributes everything all at once, you can sort of do it one at a time within each polygon. So I'll show you another example later on, some workflow of how this can be used in conjunction with the other thing that we've added in the attribute manager. So in terms of new attributes, in terms of new provided resource, that's one of them. And the other one we've added is the niggly diagrams. So it's grayed out, unfortunately, because we don't have all the columns that we need. But we found that the niggly diagrams are really useful alternatives to things like molar ratio diagrams and that sort of stuff. But yeah, have a look at this. One of the so the author for this, Ian McDonald, he's gonna make some videos talking about this new version of the niggly diagrams. So we've added niggly diagrams in the previous version, but in this version we've added some ternary plot variants of the niggly diagrams, which is quite useful because you're instead of looking at just two variables, you're looking at three at the same time. All right, so while we're here, I'm gonna just open up a different file, and I'm gonna talk a bit about the improvements that we have made to the geotiff underlay that we have in GAS. So we've added this in the previous version of ioGAS, but we just made it a bit better. And what that means is that if you have a map like this, you can import a geotiff layer underneath your attribute map, and that's what that looks like. Okay, so we've added this in the previous version, but maybe some people haven't seen it. But the difference is now you can actually load a number of different geotiffs. I'm just gonna load a few. And basically what this allows me to do is that you can load multiple geotiffs and then just toggles between different ones. And the great thing about this is that if you open up a different plot type, like a variable map, for instance, you can go to the geotiff config dialog and actually just use whatever geotiff you have imported into your session. So think of it as like a library of geotiffs that you have imported into your workspace, and you can toggle it from any file type that you have in GAS at any point in time. So you can have your attribute map displaying the map grid, and then you have your geology map displaying underneath your variable maps and that sort of thing. So that's the biggest change that we've had in the raster underlay geotiff importer. Now we have a manager for it. Okay, so another thing that we've added while we're here is I want to show you that the select points tool, so the flash highlighter or the select points tool, now has a has a number in the bottom in here. So I don't know if you can see it, but in the bottom, you can basically see these are the number of rows that I have selected using the flash highlighter, and actually shows up here in the bottom. So it's quite useful because it, yeah, basically just allows you to see how many rows that you've selected using this tool at any point in time. All right, so let's open a different data set. And we're now going to go into sort of the final part of the presentation. So I'm going to use a couple of files. But this is basically, you know, if you've attended our ioGAS training before, you might have seen this file, but it's just a bunch of drill holes. So I can see it in 3D like this. And basically the workflow that I'm going to show you is the changes that we have made in the attribute manager. All right, so if I start off with just a scatter plot of SiO2 versus Fe2O3, like this. So, you know, that typical workflow, you know, in ioGAS where you have to create a bunch of new color groups like this. And then you got to select each one in order to put things into color groups like that. That was the old way that we did it. And in this version of ioGAS, basically what we've done is every time you click on attribute polygon, and if you don't have anything created or selected in the attribute manager, the moment you do this, it's going to ask you, do you want to create and use a new color attribute? And you can keep doing that. And again, it's going to keep asking if you don't have any color group selected. It's going to keep asking. And so if you don't have any attributes selected, it's going to keep asking to create and use a new one. So that allows you to pretty much rapidly create color groups as you wish, you know, as you attribute your data points like this. So that allows you to do, you know, if you're familiar with that Scott Haley type workflow, instead of creating color group and doing it every time, you can start to find your clusters manually and attributing them into color groups as easily as, you know, keep on clicking using the attribute polygon function. So that's quite a big thing that we've added. And it ties in quite well to, you know, the way that we've improved the color attribute strip log. So if I go like this, right? So if I select a text column and a couple of numeric columns in here, and if I just select, I don't want to select everything, so I just select a couple of these drill holes, open it up as a drill hole plot. So by default, now we have a thing called the color attribute manager strip log on the left. So you see that the color is black in here, and that's because the attribute manager, we don't have any colors activated, or we don't have any color groups present. But, you know, as I do this, you can see how the colors change automatically on the color attribute strip log. And that allows you to do that rapid attribution and see that change being reflected in real time in your data, right? And you can kind of do the same thing. You can do the same workflow in here as well. So, you know, you may notice that in this instance, you might want to split this into several groups. So, you know, what you want to do is, yeah, so you can do your attribution in, you know, not just your scatter plots, but it works in every plot that supports attribute polygon. So it just triggers you to do it in every step of the way. And this ties in well to what I was showing you earlier. If you look at things like a classification diagram in here, so a typical workflow is, and I show this all the time in my training, right, using this data set. If you have, you know, you have your log geology, so you have your 3 rock types like this. And if you want to split felsic A, let me just show you. So we have this rock type called felsic A, and you see how it's split into 2 groups in here within the basalt field and the rhyolite dacite field. So, you know, it's a classic case of mislogging. The classic way of putting this into 2 groups is you can either do things, you can either do this using 2 ways, right? So you can create a new color group, and then you can assign that to that group, or alternatively, you can click on attribute by color rows by polygon, which in this case is a bit manual because you have to delete it and start all over again because it color attributes to all polygons at the same time. But now what you can do is you can do this workflow, and you can right click to a polygon and do it like this. So of course that being the same color, but you can see that it's putting things that we call as basalt into its own group, and that's it basically. So it's quite a fast way of actually doing things now. So instead of the classic way would be you turn on Felsig A. I'm just gonna undo and show you sort of the traditional way. So the traditional way that we did it before would be like this. You create a new color group, and then you assign it to that group like that, and then you do it again and again. And it's quite a laborious process, but now we just made it a bit easier. You can just right click to or attribute based on where the polygon is sitting. Right. So that's one way to do it. So those things sort of go hand in hand. And you can see how those changes are reflected in the color attribute strip log. So by default, I think it is on, but you can always turn it off if you don't use it. You can turn off the show attribute manager strip log if you don't want to, and that's accessed from default preferences. All right, so another thing that I want to show you is that if you're working with a multi-element data set, chances are that probably they're not of the same unit. Which precludes you from using the stack multi-trace plot. So I'll just show you this sort of for context, but a multi-trace stack plot is usually used for something like a downhole data from aiGAS. So you have spectral contribution of each mineral, percentage from 0 to 100. But you can also use it for assay data. But the challenge with using it on assay data is that, of course, if you have some things in ppm, some things in percent, the ones in ppm will overpower the ones in percent, of course, because of the difference in magnitude. But in 8.3, it's actually going to flag it to you that not all selected alias columns are in the same units. And it's going to say, a stack plot will be misleading. So doing a unit conversion first is recommended. So it only tells us that, but it's actually going to do it for you. So it's going to convert everything into the same unit. And because most of the columns that were selected are in ppm, so it's going to convert everything to the same unit, which is ppm. So it's going to do that, and automatically brings up the stack strip log that we have in here. So that's one way to do it, right? And you can see that everything now is all in the same unit, and it just plots it up automatically from here. So looking at the downhole geochem in here, we can see that the variation in the stack strip log kind of tells us the boundaries in the data quite well. And I don't have any color groups here selected, but what we're going to show you now is I'm going to show you the Python integration that we have, or the Python script runner that we have in ioGAS. So I'm going to run you through a couple of workflows, and I'm going to show you how the Python script runner can actually be used to load some algorithms that you probably wouldn't be able to do in ioGAS before. So I'm going to start with running things through a UMAP tool. So we've added the UMAP a few versions ago. I think we've added in version 8 of ioGAS. There's a dimension reduction technique, and the output is basically what's called a UMAP plot, and it's a 2D representation of the data where groups of data points that are close to each other in the UMAP space, they're close to each other in the high dimensional space, which means that if they're close to each other in the UMAP plot, that means that they're more similar in the input data space. So they're more similar across the variables that you select. So from what we can gather from here is basically the different clusters that we see here basically represents clusters of data points of similarity, between the data points that are close to each other in the UMAP space. So the human eye is really good at finding clusters, especially in a low dimensional space. So, using our eyes, we can see there's 1, 2, 3, 4, 5, 6, about 10 clusters in here, right? But we're gonna pick a more automated way of doing it. And there's an algorithm that we use called HDB scan. So, if you look at a clustering thing, there's actually already a thing called DB scan. So it's density-based spatial clustering, but there's another one called HDB scan, which performs a bit better. for this purpose. And we already had dbScan, so HDBScan is sort of an alternative to dbScan, right? So it performs better in some circumstance. So that's why we have added it as I'm gonna show how to load it as a Python script within this Python script runner. So the Python script launcher in ioGAS can be accessed from the workflow ribbon. So in the workflow ribbon, you can click on this button called Run Python Script. So you can see that it has that little Python icon in there. So just click on that. You can find that in the workflow ribbon, and then just navigate to the folder where you have the Python script. And actually, what it does is it will run it on the variables that you've selected in the Select Variables dialog. So I actually need to go to the Select Variables dialog, and I need to select the columns that I want to apply the clustering to. So I want to apply some sort of clustering algorithm to these two dimensions, to these two UMAP columns. So click OK, and then I'm going to click on Run Python Script. I'm just going to navigate to my HDB scan script, and I'm going to show you what that looks like. So that's what that script looks like in Python. So when you want to bring in when you want to use this on your own, we ship a couple of Python scripts in our installation folder in ioGAS. But if you want to try this yourself, and if you're already using Python, all you need to have, you need to have pandas and NumPy installed in your Python environment. And there's a few other ones as well, which you can see in our help file. But if you're already using Python for your geological work, then chances are you already have you already have your environment probably set up in a way that you can run it pretty much straight away. So yeah, anyway, I'm gonna run that HDBScan script that I showed you earlier. It's gonna run it on those columns that I've selected. And the Python script runner basically allows you to set it to just run on multivariate rows only. So multivariate being running it on rows where you have data across the columns that you selected, and feasible rows, so it takes into account the state of your attribute manager. So you can run a Python script on a subset of your data. So if you set a bunch of rows to invisible, you can only set it to, you can run Python script on the feasible subset in your data, basically. And then you have a couple of other parameters here to choose from. One of it is, if you're running a function in the script that has some parameters that you can configure it using the advanced options. In here, you can add keyword arguments, and then you can either configure it in the script or you can configure it within this dialog. But anyway, let's just try to get it to run and click OK. And it's really fast because it's quite a simple algorithm, but it takes that UMAP column and it creates a new column called HDBScan cluster, which is the output from that clustering algorithm. So how does this Python scripting works? Well, basically, it takes your workspace in ioGAS, and then it transmits that as a JSON file into Python and puts it into a Python data frame. And then once it's in a Python data frame, it just does what you set the script to do. So you can use some of the scripts that we ship as a reference, but that's basically what it does. And what this does is just it takes the UMAP columns, does some clustering, and it outputs a result. And the resulting column is what's get pushed back into ioGAS, and it's this column called HDBScan cluster. So if I go to my column properties dialog, you can see that it's generated a new column called HDBScan cluster, and I can change that into a text column because it's the output is just a bunch of numbers basically. And then we can see how that cluster looks like in the UMAP space. So there you go. So you can see how the HDBScan result, how that clusters your UMAP, and you see how it changes how that's reflected in the stack strip log. And of course, you can see what it looks like in 3D space as well. All right, so the other thing I want to talk to you about is the classification tree in ioGAS. So we've done a bit of work on this. So let me select the same variables that we use for the UMAP. So this decision trees or classification and regression trees have been around in ioGAS for a long time. But we've made quite a number of changes to here. So you can now zoom in to classification tree. So you couldn't do that before. And this becomes incredibly handy if you have a large, like a really big classification tree, and you want to sort of pan and scroll your view like that so you can zoom in and out. So that's one thing we've added. You can do that using the right-hand side toolbar. There's the two buttons on the right. Or you can hold down the control key on your keyboard and use your mouse wheel. So whatever you want. And then you also have the confusion matrix in here. And a confusion matrix allows you to do the same thing. So you can hold down the control key to zoom in and out, or you can use the options on the right-hand side toolbar like this. Okay, so, and the same principle applies to random forest as well. So if I build a random forest, it's going to wait for it to finish. But the output of a random forest is another confusion matrix, which you can zoom in and out easily now using your mouse wheel or the option on the right-hand side toolbar. Okay, so then the thing about the random forest here in ioGAS is that now we can actually save it. So, before we can only save a classification tree as an XML file. So we've always been able to do that, but we haven't been able to save a random forest. But in this version of ioGAS, we can now save a random forest as an XML file, and then we can reuse that later on. So I'm gonna save that as an XML file. And what I'm gonna do now is I'm gonna import. I'm gonna add new rows into the file. So as you can see from here, I only have like 6 holes in here, and I want to add a few more drill holes into my workspace. So I'm gonna use the append function in here. Before I do that, I'm gonna minimize everything so it doesn't look too messy. And I'm gonna click on the append file function. And you can append anything into ioGAS. You can append an Excel spreadsheet, CSV, text, or a gas file. So I'm just gonna add new rows into my file. And essentially, because I'm bringing in data into an existing table that already has some calculated columns. Once I've done this, it actually will recalculate the columns that I already have. So I already have some ratios in there, from the geochemical diagrams that I made, and also the columns in different units. So remember that when we did that multi-trace stack strip block, we convert some of our data in percent into elemental ppm. Well, those things get recalculated as well for the appended rows. So this is something new that we've added in 8.3. In previous version, when we add those new rows, the data in those columns will be empty because ioGAS doesn't recalculate data in the appended rows. But now we recalculate the columns for the appended rows. But it doesn't recalculate things that are non-parametric, so things like the result from your UMAP or clustering or things like that. So anyway, if you look in the data view, in the columns for so this niobium and yttrium, zirconium, titanium, so those are the 2 ratio columns, and you can see that it's populated down into the appended rows as well. And so if I open up that classification diagram that we had earlier, so you can see from here, this is the list of a group by plot type. You can see how it's sorted by plot type now, and it's even alphabetical as well. So you can, if you have a session where you have 50 different types of plots, you can sort it easily either by alphabetically or group by plot type. So anyway, this diagram actually has data across, so so the ones that I've highlighted in here, these are all my appended data, and they've been recalculated and being placed into this classification diagram, which is quite a neat thing. That means you don't need to recalculate the columns if you want to, reopen the same diagram and that sort of thing. And most importantly, it allows you to do that, classification and things like that. Okay, so one last thing I want to show is I can open a save random forest by going to the random forest option and then click on Load Random Forest in here. And that allows me to select that random forest. And what it does, it will just automatically create that random forest classification, just reapplying it to the data. And then I can use it straight away to auto attribute my data just based on the result of that random forest. So remember that this random forest was trained on a subset of the data. And we're applying the safe random forest into the data that's been depended. Okay, so I've shown you that, and I'm going to show you a couple of things before we finish off. So another thing is, if you start off with no file imported at all, you can utilize the import via Python function. So this is another alternative for you to bring data into ioGAS. So if you have a Python script like this, I'm going to show you. So I've made a Python script that processes a LAS file. So maybe some of you have worked with LAS files before, but a typical LAS file. I didn't show this in my morning demo. I'm just gonna show you what this looks like in Notepad. So yeah, pretty typical LAS file. You have your all of this information at the top that you don't need when you bring it to ioGAS, and then you have the actual data in here, right? So what you're interested in, what you want to bring into ioGAS is just these columns and the name of the well. And this is from our Nova XG tool. It's a very old data, but basically what I'm going to do is I'm going to open a Python script that strips that last file and bring it into ioGAS. So I click on the import via Python and then navigate to that script. So this is when you don't have any file open in the first place. You can use this to strip out, extract data from outside of ioGAS and then bring it into ioGAS in that way. So that's what we call sort of an import script. Okay, so I'm going to do that and click OK. And it actually just strips out the information that we don't need, and it adds it into ioGAS. And you can see from here in the data view, yeah, so it's just bringing in the name of your well along with your information that you want to plot. So I'm going to plot my gamma data down the hole in my strip log, basically. And you can do, once it's in ioGAS, it's just another way for you to bring in your file into gas, right? So yeah, all right. So before we finish off, I'm going to show you a couple of ways that we can export data out of ioGAS. And if you want to, for example, if something that people do quite often, if they tend to plot, the same kind of plots every time. So every time they want to export a probability plot for QA/QC or for just reporting the result from your assay lab, you can right click on any plot, as to export a plot. But now we've added the ability to sort of standardize the way that you export things out of ioGAS, right? So you can, for example, if you always want to save things into a certain size, 800 by 600 in this instance, and I'm just going to export it to my desktop just so that it's easy to find. I can save my settings. I go to my desktop. Let's see, where's my desktop? Right, so I can see that that's been imported in that 800 by 600. So it's exporting it sort of in the size that I want it to. And then if I right click on any other plot in here, I can choose to either use the screen setting, which is what the default is, and then I can also choose to use the save setting. And that's kind of the same thing with other plots that we have in here. So it allows me to sort of standardize the way that I can spit things out of ioGAS. And it also allows you to, standardize the way that you export batch plots like this. So if I do it like this, right? So it's going to export everything in here into the same dimension. So it's going to bring up a whole bunch of different plots. It's quite a lot, but look, they're all plots of the same type, so or sort of the same size and dimension. If I just right click, you can see that the dimension is all sort of the same, 800 by 600. And the best thing about this is that you can sequence that in a workflow. So you can record a workflow. Remember that this is one thing that we've added a few versions ago. So it's like a macro recorder. So if you export the same things every time, you can set up a macro or a workflow that records the action of exporting plots outside of ioGAS. And one thing that I didn't mention is that we might have some Mac users now in the webinar, but one thing that I didn't mention is that with the Mac OS version of ioGAS 8.3, to install ioGAS, you will need to drag the app into the applications folder. And another thing is that you will need to run like a startup script to move user files, including license files and user configuration into ioGAS 8.3. So please refer to the help file or the user guide that we have in our website, and along with information that you need if you're a Mac user. But that's just one thing to keep in mind. So another last thing that I want to add is this tool called aiGAS. So aiGAS is a chatbot that's built based on the ioGAS help file, along with a few other information. So this button is not available to you all, but there's a configuration that is that can be enabled to have it available from within ioGAS, and there's also a URL that you can type in order to sign up for it. But this is basically aiGAS, and it's a way for you to interact with the ioGAS help file, right? So the ioGAS help file is still the main source of truth for a lot of the information that you need to get started with using ioGAS, right? But aiGAS allows you to interact with it, and there's a few other things in there as well. It's not just the ioGAS help file, but a few other documents that can add a bit of context to how you can interact with learning more about ioGAS. So say for example, how do I use PCA in ioGAS? Right, so you can ask something like that. And Dave is right. Just don't ask it for financial advice. But you can ask things like this, right? So how do I use PCA in ioGAS? And it just gives you the steps to do it. And you can even run things like what is the best digest method to get good titanium and zirconium value. And there's a couple of documents that we've added that allows you to get some sort of that information. And actually, if you read it, to obtain accurate values for titanium and zirconium, it's recommended to use your 4-acid digest. So things like that. So there are a few ancillary information available to you as well, and also things like simple things like for example, I see Heidi put a question in the chat. So how do we make oops. So I'm gonna see actually if if we can if it can answer your question. Actually, it does. So how do we make plot axis names bigger in ioGAS? And it just tells you you need to adjust the font size settings for the axis labels, and to do that, open plot window style settings, which is this thing on the right. So yeah, you can change it to whatever you want. So I'm just literally just gonna follow what it says, but yeah, there you go. All right, so that pretty much sums it up, right? So aiGAS is sort of open to the public for those who are interested. Just let us know. We're sort of in the process of trying to organize how to get people registered to it, but should be pretty straightforward process. But if you let us know, we'll add you to the list, and we'll contact you with the steps on how to start using it. We're just after some feedback at this stage. But it's, again, as I said, it's another way for you to interact with the help file in ioGAS, along with some other information that you need in order to learn how to use the programs. probably more useful if you haven't used it before. But if you're an experienced user, there's a couple of things that it can give you, perhaps something that you haven't picked up before in the past. All right, so let's finish up. So just in summary, 8.3, the biggest things that we've added are things around the drill hole sort of module. So we get the color attribute strip log, and we've added the tadpole and scat plot. Added the ability to join point table to an interval table on top of the existing interval to interval merging that we had in 8.2. And then we can execute Python scripts from within ioGAS, either to run things on an existing workspace in GAS or import data into ioGAS using Python, basically. And it allows you to do a bunch of different things, right? So there are interesting use cases that we have tried to use the Python script runner for. So we've run it for things like calculative mineralogy, and things like even doing things like desurveying sort of ioGAS and bring it into GAS. So there's many different things that you can do with the Python script launcher, and we're really keen to see how people are using it actually. And a few of the other things that we've added is really just improving accessibility, with the single installation launcher. So just making it easy for people to bring in large data sets to ioGAS without having to open up different executable files every time. And those changes that we've made to the attribute manager, that should, streamline and speed up the way that people have usually done things before, especially when they use that type of workflow. So we just make it a bit faster and easier for people. But that's basically it. Thank you, everyone, for taking the opportunity to come and listen to me go about ioGAS 8.3. But hopefully you find that useful. And I'll see you around. And if you have any questions at all, please let us know. And if you have any interest in trying out aiGAS, please send us an email. You can contact us from our website, from index.com. Or if you have my email address, just email me. Thanks, everyone. Have a good evening, morning, or afternoon, wherever you are. Thank you.